Right, ladies and gentlemen, I think I am live. I'm so used to looking this way, but now I'm looking this way because for whatever reason, I don't know, my camera's not working. So it was, hopefully at least my mic is working all right. But yeah, I was making videos earlier today. Finally got done with my 30-day challenge videos, which was took me a lot longer. I did for those of you that are on. Hopefully, you guys are still in there. We're I think on day 20 or I guess whatever today's date is here, right? Yeah, so we're on day 21 of the 30-day challenge, um, and yeah, but I had to go and finish. So I did 31 days, 31 questions for pre-calculus and algebra 2. So that's 62 questions, and I just finished it up. But anyways, welcome, ladies and gentlemen, to week 64. My name is Mr. McLogan, and I am here to answer your questions. And then also, I wanted to talk to you a little bit more about becoming a teacher and some of the things that I did not expect to be when I actually became a teacher, or at least maybe up to this point. So I do apologize. I'm coming a little bit different to you, and I'm not sure how I look. And you know what? I was just like, whatever. It's already late past the live stream. I think some people are also on their spring break time. So we well, Addie, thank you so much for joining back in for you. It's always great to see you on, and I do appreciate you always joining in. But yeah, definitely want to make sure you're taking care of yourself first, though. Okay, but yeah, I think we only have a couple of questions, and I do apologize, guys. I did not get to was able to get to everybody's question in. I kind of got to the live stream a little bit late, and that's why I was like having the technical difficulty, and I was like, what's going on here? Because I literally was making videos for a couple hours today, because that's basically my life. And then of course when I go live, I couldn't figure out the video, and I'm like, well, you know what? I'll just talk to this person, even though it's gonna be kind of weird because my screen that I work my videos on are right here. So we'll just kind of get this going, and then you guys get the nice picture of my eye. So great. But that's the way things roll. So Sophie asks, what happened to your face? And COVID, do you do SAT prep? No, I don't specifically do SAT prep, but that is something I'm looking into, at least adding into some of my short form content, kind of incorporating a little bit more of those videos in my YouTube shorts as well as TikTok. So keep up for them. I took a little break from some content strategies on my channel just because I needed it. And but that is something I'm looking to incorporate here coming up. But Sophie asked what was going on my face. And I always want to talk this way because that's the way I'm going. Yeah, I fell off my bicycle on a morning ride, and my face hit the pavement. And if you've been on my live streams, you can just look like a couple weeks back and you'll see my face looked much worse. This is actually much better. So this is actually all healed up, and I think it's just kind of coming through now for this. And at live streams, we have intelligent people. And yeah, he said, it's a good thing. A lot of brain power for sure in here. And then also, guys, if I do apologize, there's a whole bunch of questions I was not able to get to. But just remember, guys, if you do want to submit a question, you can always go ahead and submit questions on my Google form. That is a link inside of this channel. And then also, have any questions? And then also, if you want to join the Discord server, then you guys can also go ahead and do that as well. And I will go ahead and post that link in here, and I will pin it up top. Yeah, it's like ads in there. So weird. There you go. Hopefully that works. Cool. All right. And then I'll go and pin that in there for you guys. So therefore, you can go and check out the Discord server. If you are not familiar with answering questions on Discord, there's a lot of really, really smart people on the Discord, and it is awesome for people helping. We have people that are set up as tutors that help people out. And I always tell people, ask a question, help other people with a question, because obviously the tutors cannot get to everybody, but it is a great community of people helping other people with their math. So if that's something you're interested in, please go ahead and check it out. Also, you can always submit your questions for me each and every week, and I will try to do my best to get to them, but I make no promises, guys, because sometimes some weeks I have a little bit more time than others. And today was one of those days where I just got right into the stream. I had to I noticed I had a low amount of questions, and I kind of underestimated how much time it would still take for me to prepare for the stream. and I wasn't able to get to all of them in time, and or at least just like look at them and see, hey, sometimes I could just grab problems just as they are, and then some problems I just got to like reread them and make sure I like understand what they're asking. And I didn't have time. If I didn't know what it was doing or like where the problem was going, I just like had to skip it. So I do apologize for that, guys, but you can submit them every and every week. I am here. All right. Right, Rash. Okay. Can you start your stream earlier? Yeah, I'll try to go and do that. As far as right now, the stream was, this has always been my stream time that I've had for the last couple of years. And I'm probably going to keep it here for at least a little bit longer, until maybe next school year. And then we'll maybe make some adjustments, from there. But so we'll definitely go and see that. Well, awesome. Chloe, pop and say hi. Well, thank you so much. And Glenn, have you considered contests focusing on discrete math? Yes, Glenn, I have. I've focused that a lot because I think the future is really in a lot more in discrete math. So that's really interesting you asked that question because, yeah, I think I want to focus a lot. And right now, mostly the stuff that I focus on and teach is just because that's what I'm based on what I'm teaching inside the classroom, so I'm a little bit limited with that, or at least as far as my capacity, but I am looking forward to at least ending the school year and being able to put more attention into stuff that I'm not directly teaching. Like this year I'm teaching algebra 2, geometry, and pre-calculus. And I want to put a little bit more time into discrete mathematics and as well as like calculus. I think those are some things that students would benefit from and also just broaden out my channel. Even though I do have some content, I don't have a lot. A lot of my content is mostly algebra 2-ish, pre-calculus type of content. Well, Kim, sounds like you have a very nice message. Thank you for your YouTube videos. That helped me very much. Moves or the other videos sound so dead inside. Hope you have a successful life. Well, thank you so much, Kim. That was very, very nice for you. Discrete math is basically broken up math. So it's basically looking at so when you think about like functions, those are like continuous, right? Connected functions. So discrete math is not looking really at that continuity. So if you're thinking about a lot of, you can think of like probability and like set theory. We're not dealing so much as far as the continuity in like functions. It's just maybe a very basic way for you to kind of understand the difference between discrete math or finite math and like a continuous, functions kind of math, which would be more based in like the calculus kind of realm. Even I found your way. Very interesting. Well, thank you so much. Thank you so much, guys. I appreciate it. And it's so weird having talked to you like that. I want to maybe see. I think my video is still on. So let me just see. Let me see if my mic, I'll try it one more time. I don't know what's up. Nope. See what happens? See, it just goes. I don't know. So I probably have to like turn it off and I'm not going to studio with it. I'm not going to studio check it. That's fine. All right. Oh, you guys getting some questions. All right. I think you and Eddie, we should do a clap one day. I know. I definitely think we should too. I'll have to maybe see if I can if you guys can get a hold of him. That is my goal. He is a awesome inspiration. I love watching his videos as well. And I think he has that natural ability that speaks to students as well as just to humans that I think is really inspiring as a teacher to see. So yeah, so I'll leave it up to you guys to get to reach out. Hopefully you can get him to connect. But thank you, Ethan. I really appreciate that. So the Mockingbird said, do you have any advice for improving general problem solving skills? I'm doing well in pre-calculus, but I'm worried about the abstract thinking that seems to be involved. Yeah, it's hard. And you're not really going to like my advice. But I think one of the best advice is for general problem solving skills is just to do more problem solving. Like you got to practice because I think the more you get exposed to the different types of problems and how to approach the different types of problems, the better you're going to get at it. And I'm not really sure if there's a shortcut or something that I could say to you that's going to like click and be like, oh, this is easy now. Like problem solving is difficult. Like thinking through math problems is tough. So I think just in general, the more problems you can work through and practice, the better you're going to get. And it really is as simple as that and as non-great to hear as that, because yeah, I know it's not fun and it just means more work for you. Right. But I really do believe that is something that can help you out. And I'm not sure if there's a like trick or a tip I could just give you that would really help you as much as that advice. In the middle, like my teachers, you're all well, thank you so much, Stephanie. I do appreciate that. And yeah, I want to, some of my videos have been getting a little bit, I've kind of like played around with a little bit longer form content. And then I'm kind of like, it's always about balancing that. And one of the things that's really been great about the 30-day challenge is like making a video in a minute. It really makes you as a teacher really kind of think about like, what is the most important that people need to hear, right? Like if I need to teach this in a minute, like what is the most important? Like sometimes I use double time if I like want people to see my work, but it's like, it's really is interesting to get out really out of the fluff, you obviously want to teach and explain things, but you also just don't want to over elaborate on stuff that people don't need to hear. And so yeah, it's been a really good experience doing those YouTube shorts and trying to keep everything in under a minute. And I'm just answering your questions. I haven't even got to my what do I expect to become a teacher, so I guess I'll get to that. But I appreciate you guys answering these questions. You guys are bombarding me, so I like it. All right, hello, are you teaching GED test prep? Thank you so much. I am not teaching that, but I do have a lot of my stuff on my channel, as I mentioned, is like Algebra 1, Algebra 2, pre-calculus. So I think a lot of that would apply to GED. And then I think I also have like some SAT, ACT, kind of test prep that I would just recommend, checking out on my channel. I have playlists for that I think a lot of those questions would correspond to GED, even though I'm not familiar exactly with a GED test prep, content. I think some of that would at least help you be good for you. All right, Iset. Well, it was very happy to help you out. Thanks so much. I'm taking pre-calc per in college. I was just going to ask you if you can help me. Yes. As of right now, how's your... I fell off my bicycle. That's what happened to my face. All right, I will go ahead and get to open questions here in just a second. And Frozen Art, I am teaching geometry at the moment. We are just finishing up circles, and then we're going to get into three-dimensional shapes. So it kind of stunk. Like when I first started teaching geometry, I was so excited because I haven't taught geometry in 10 years. And I was like, man, I'm going to like make videos, like I used to. Because some of you my geometry videos, they're like 10 years old. And so I was like, oh, I'm going to refresh all my content. And then, with COVID, it's like I'm wearing a mask and it's just awkward. It's weird. It's just, it just doesn't have the same flow. And so I was like, you know what? I can't do this. I can't record videos like this. And then the only other time I can record videos is after school, after I've taught all day. And that's very time consuming and also very exhausting as well. So, it's been kind of difficult, but either way. All right. So let's go ahead and talk about timestamp here, 9:18. Let's get into what did not expect with Became a Teacher. And I'll get to any of your questions if you guys do have. I have a short amount of questions for tonight. So I think only 6 questions. So if you guys do have any questions, math questions, I'll try to do my best to be able to address you guys after the 6 questions. And again, if you do have questions, feel free to go ahead and ask them in my go to that link, or you can go to the Discord and ask your questions there, as we have a great community of people helping and answering questions. Well, thank you, Frozen Art, subscribing to my channel. I got to get to 1 million, guys. And that's really going to be a push that, I made the push and then I just kind of I just had to like step away. Not really step away. I was still going live and posting videos, but yeah, one of my goals is to, as I mentioned, like a couple of the live streams, I keep on talking over. You know what I'm going to do? I'm going to turn this off. Okay, so one of my goals was to get to 1 million subscribers, and I'm like, yeah, I got to do it. So let's go on over there. So yeah, I saw my camera on thinking it's going to work, and it's not going to work. So I was like looking at it, like talking to you guys, but like, no, you guys are over here. So, all right. So what I didn't expect when I became a teacher. So if you're on my email list, I sent out an email today. And one of the first things that I wanted to mention, like on my email list, was that how involved teaching really was. Like, not so much as like involvement like inside the classroom, but how teaching really just like becomes a part of your life. And, like it's hard to really kind of describe like my brain as it like works. Like I'm obviously doing this YouTube channel, right? But I got school tomorrow. Now, obviously, I mean, if any of my students are on, I don't actually, I have no students tomorrow. So it's a little nice. We have a planning day because it's the end of our third quarter. But typically every Sunday night, this live stream is actually kind of tough because my brain is literally already thinking about like tomorrow, right? I'm thinking about my plans. I'm thinking about what I have to do in my classroom. And it feels like throughout the week, my brain is always thinking about teaching. It's always thinking about the next day. Like I never do anything on a school night. And I remember I used to always get so upset, when I was in high school, because like my parents were like, no, you can't do anything, on school nights. I was always in sports. But like going out or like doing anything fun like on school nights like just didn't happen. It was like, grades, and that's what you were doing. And it's funny, like as a teacher, I'm like, it's very difficult. Like when I do something on a weeknight, if I do have to like have something be done, it's very difficult. Like, because it's like, I'm just throughout the week, I am so involved with being a teacher. And I think it's very, good and healthy, but it's also very hard sometimes, that like, to really disconnect, sometimes you need to. And it makes those weekends like, so I need this time, for myself and to recharge. And I think that's why a lot of people, they don't understand when teachers are like, I need this break or this extra day. Like tomorrow means so much to me. And, this is like a Sunday night where I'm not stressed or thinking about what I have to teach the next day or how I'm going to teach or how the day's going to go or my lesson or what I have to grade and all this kind of stuff. And so yeah, I mean, those breaks really, really matter as a teacher. And I think that like, even though the classroom day ends, like teaching just kind of like stays with me. Even if it's not so much always work, I'm always just like thinking about the teaching and what's going on in my classroom and what I have to do and like the interactions and the emails and like everything. It's just a very involved job. And you always hear like teachers talking about like teaching after school and, like, and Sunday nights and grading and lesson plans and blah, blah, blah. But like, for me, it's always about like, I didn't expect my brain to literally just be like always in teacher mode. Like I'm literally throughout the week, always thinking. And like, when it comes to like that Friday and Saturday, I'm just like, it's a decompression. I mean, it's just like, just relate. And, it's hard too, because what's my secondary job that I like to do? It's math teaching online. And it's like, you're not giving yourself a break, but I still enjoy it. I mean, obviously I wouldn't be doing this for over 10 years if I didn't, thoroughly enjoy that kind of stuff. But yeah, it's how much involvement you are involved within your job was something that I kind of knew was around, but I didn't really, I guess maybe I underestimated how much, an investment that is. So the next thing is like the attachment. And I think one of the, one thing is I didn't think was like how attached I'd become to like my students' success, how attached I'd be to like my school, how attached I'd be to just like being a teacher. And like, I think just being like that role model, for students, it's really kind of crazy. It's I have a really big, what's the word? Now it's kind of coming to my head, but I'll guess I'll just use an attachment because I can't think of it. Like a really down attachment to like my school and becoming a teacher and my students. Like I literally, even some like people online, I take the ability that, I tell my students all the time, like, once you're my student, you're always my student. And I think that is something that the kind of stays with me. And it's really weird. It's like, once I know students have invested inside of my class, like I have that attachment that I want to do whatever I can possible to help you be successful. And I even take that for, a lot of people as well that, that are on my videos. Like I feel like a lot of you are my students as well in a similar kind of manner. I mean, obviously I don't know many of your faces or if any of your faces, but it's this weird kind of attachment, that this kind of relationship, that teacher student relationship and the ability to see people through their struggles, brings an attachment that I'm like, I want to do whatever I can to, see that success. And like, I saw that attachment when I was like a coach or when I was a player, with my own coaches, but I guess I never really thought of it as, what I would have for like a teacher. And it's just amazing, like seeing students down the road, and seeing like this, you're just still so attached to wanting to see the best for them. And yeah, it's just kind of a crazy kind of feeling. Number three, I mentioned in like the never wears down. Now, I didn't mean teaching never wears me down, because it definitely wears me down. It wears me down every single year. Like I said, even the last 2 weeks, I didn't make one math video. I was just like, nope, I'm not doing it. So the video I posted the last like 2 weeks were ones that I made like a couple weeks ago. I was like, just can't make a video. I was done. It was spring break. Parents were in town. And I was just done. So but the cool thing, what I was saying was never wears down, is like every August we go back to school. Every August I get excited to go back to school. Right? Every time, like around April or May, I'm just done. I just can't, I'm crawling myself back into school, because what it is, it's just, now it's prep time to get students into testing season. Right? And it's just, the whole year's ended. I'm just like, I'm done. I can't teach anymore. It's, I got to get myself out of bed, get myself motivated to teach. It's very difficult at the end of the year. I'm just like my students. And then it's funny, like every year, no matter what, you're like, oh, here comes a new year again. And you get excited, new lesson plans, new students. And it's just kind of funny. It's like that cycle that just keeps coming back. And yes, it does wear me down, but the fact of like that cycle of like a new year, new students, new opportunities, every year, it's just the same thing. It just keeps on cycling back. And I always thought that was something, that was really cool. I think the other thing was, I was talking about the grades. So the stress and the demands was, I think this is something that's actually involved a little bit more since I've become a teacher. This wasn't as much when I was in high school. It wasn't as much when I first became a teacher, but the things I didn't expect, that at least now I don't expect, from then, I think things are going to change, and I hope things change, because COVID has really impacted the ability of, I think, students and teachers to really, get what's best for us in an educational capacity, because it's turned to this point where, nobody really cares to learn. A lot of students aren't in my class to be learning the content. A lot of students in my class literally for like a grade. I'm like a vending machine. It's like, oh, I'm coming to your class. Give me the grade that I want, and then I'm moving on. Right. And it's almost like this, oh, wait, did I miss the super chat? I just saw the super chat and I'm like, oh my God, that's so rude of me if I didn't say anything. Hey, Senkud, Sanruki, thank you so much for your super chat. I am so sorry for not addressing the super chat. You are awesome, and I greatly appreciate that. I was just talking my mouth off and I didn't even see it. So thank you so much. I was like, just noticed that like super chat and I was like, oh my God, I gotta thank you for that. Thank you. So the point that I want to break is like, a lot of students, they have, the grades are so much of the importance. I mean, because it's to get a good GPA, go to a great college, right? Get a good job. And that's the system that we built up for so many years. And I didn't really and obviously I know the game, the game was the same when I was in school. And then, so I understand the game, but I think as it's gone on, I think it's gotten worse and worse, where I said, it's literally come to the point where some students will get into my class. If they're not getting the A, if they're not getting a B, it's like, oh, they're out. Right. And, for some students, like, okay, that's fine. They're just, shopping for a grade. But some students are like, I want to become an engineer, or I want to become major in computer science, where I'm like, all right, you need to know your math if you're going, you can't be shopping, if you're just shopping for a grade, then, that's fine. But if you're trying to go into like a math field or math related field, and you're dropping out of pre-calculus, that's going to be a problem. Right. And yeah, that stress just weighs out on, it weighs on a lot of students, and it weighs in a lot of parents. It weighs in on me too, because, students are, it feels like they're putting me, like the weight on me, that I am impacting their education, which I don't think teachers need to have that stress. That should not be a position that teachers are in, where we can impact somebody's, future or their financial stake, because of a grade that, we assign. So, that's a whole other topic we can talk about. But yeah, I think there's a lot of stress on students, teachers, and parents, about grades and the demands of the educational field. And I think that's something that's kind of expected, but something that's kind of gotten worse as the years have gone on. And then I said, as far as perfection, the perfection was as far as me. So I didn't really expect as far as a teacher that I'd be such a perfectionist of wanting to always improve. And it's amazing. Like, every single year I teach something, or whenever I hear, somebody else teaching, like I always want to perfect my instruction. Even though I've been teaching pre-calculus for so many years, I've been teaching geometry and algebra too. Like I'm always looking for new ways to be able to teach them, new ways to perfect the way that I can approach a topic and approach something to help other students like learn. And it's amazing because you think about something, you're like, I can't imagine like teaching this again, or teaching the same course. And like I think it's that striving for perfection of refining your explanations is really one of those things that just like kind of keeps me going. What keeps me want to keep on like educating and keep on teaching students. And it's that like that just to keep on getting better. And it's not something I really expected. I figure like, oh, you teach somebody how to do it, they know like, and then you go with that, and you just keep on moving on, or you teach other topics. But it's funny, like, no matter how many years I teach something, I always find a new way to approach it, and like it feels like every year I get better and better. Like it was funny, I was doing my pre-calculus notes. So obviously I came out with my course this year for pre-calculus. And 2 years ago, I did my notes. I was like, oh, I'm going to make this a course, right? So I did all my notes. I recorded all the videos and everything like that. And later I scrapped it. I was like, it's not good enough. I don't like it, right? So then last year, I did the same thing, re-recorded all of my notes, re-recorded all of my lessons, completely new, completely different problems, whatever else. And then I was like, okay, yep, I want to like, COVID happened. So I was like, you know what, students could use this. This could help people out that are at school or, homeschool or whatever. So I launched it. But then I was like, you know what? I'm like, this isn't good enough. I'm like, I got to redo this. So all the students that joined my course at the beginning of the year, I was planning on them using the old notes, but I was like, you know what? I can do better. And so this year I redid all of my notes again. And so I gave that to those students that are in my class. Like, and that's one of my, stress points this year is I'm also redoing all of my notes for the third time. And it feels like, and I've already thought about, next year I can redo my notes that, I can do this for my notes. And I'm like, I don't know. It's like a never ending. I just want to keep on doing better and better. Like it's great. I want to keep on refining my notes, keep on expanding my note section to help students out. So, it's kind of one of those, I'm like, dang it. Like there's a part of me that, yes, oh my God, I want to do my notes. Like I want to redo them. And then another was like, man, it takes me so long to re-record all those. I mean, that's what I was doing today. I spent, actually I woke up early this morning. Yeah. I finished up the rest of my lesson. So it was like an hour and a half early this morning. And then I did my 30-day challenge videos again today. And like, hey, it takes a lot of time. So either way. All right. That was a lot. That was helpful, or at least hopeful. But those are some of the things that I didn't expect as a teacher. And I've been a teacher for 14 years now. And it feels like each and every year I'm always learning something new. But thank you so much, guys, for joining on. It's time to get to some of your questions because I do apologize. I want to be a little bit cognizant of aware of your time for those of you that did submit some questions. I only selected, though, set 6 of them. Yeah, I was going to say 7, but I think I deleted that number 7 because I was like, I don't have time to work through this one. So I do apologize, guys. I think there was maybe like 15 questions that got submitted today, and I just didn't have time to kind of like work through them all. So I do apologize. These are just the problems that I was able to like, oh, I can go and collect these and go on from there. All right. Well, Jack, you are very welcome. And hi, Jefferson. And excuse the brand mental health and packing with work. What Shreyas says. Oh, wait a second. Okay. All right. Oh, well, thank you, Daniel. They were very awesome. You're an awesome dude. Seriously, you really deserve more than you think. I love your passion for math and your simplification of your videos. Well, thank you very much, Daniel. I very much appreciate being there for you. And I hope you're having a great school year. And I hope if you have exams coming up, you knock them out of the park because you definitely deserve it. I appreciate those kind words. All right. So let's go ahead and do some math. All right. Oops. So, Okay, so the first question is week number 50. Blah, blah, blah. Use the diagram to find the distance across the suspension bridge. Okay, so the cool thing here is I'm assuming that we know that this is perpendicular, so therefore I can say that's a right angle, right? So once I have a right triangle, I can use right triangle trigonometry to solve for x. And if that's x, well, it looks like that's x, that's x, that's x, that's x, and that's x, right? So 1, 2, 3, 4, 5, 6. So I can figure out what 6x is. So let's go ahead and redraw the triangle over here and figure out what we're working at. So we have 52 feet and we have 32 degrees. Oops. All right, so we want to figure out what x is. So again, using right triangle trigonometry, I could say that's opposite over adjacent. So I can say the tangent of 32 degrees equals a 52 over x. All right, so you're going to want to multiply by x on both sides. Of course, it's slowing down from there, so I'm not sure if I got this. So x times the tangent of 32 degrees is equal to 52 degrees, and then divide by the tangent of 32 degrees. X equals 52 degrees divided by the tangent of 32 degrees. Okay, now we just need to plug it into our calculator. Make sure you're in degree mode. So I think I have batteries off my calculator. I do, so I'll go and use a graphing calculator, but you could also use a scientific calculator. Tangent of 32. And I get a x equals 83.217. But remember, the suspension bridge is 6 of them, right? So I say 6 times 83.217, which is the rounded. So you could use the full answer, right? I'll just do times 6. And when doing that, I get 499.304 feet. I'll round to the nearest thousandth, but depends on the question, doesn't say. So I'll just leave it as that. All right, the next question looks pretty confusing. So what I would recommend doing in this case is I would recommend using substitution. I would say let a equal x squared minus 1. Now you could let any variable equal x squared minus 1, but I'm going to choose a. So I have a squared minus 11a equals a negative 24a. Nope, not equals negative 24. Okay, so I recognize this is a quadratic, right? It's raised to the second power, and it's a trinomial. And if we want to factor or solve, I believe, a quadratic trinomial, because I'm not sure if I can't remember if the directions were. So what we're going to want to do is set this equal to 0. So I'll add a 24 to both sides. So I get a squared minus 11a plus 24 equals 0. Okay, so now what I'm looking for is, what two numbers multiply to give me 24 and add to give me a negative 11. Because remember, the quadratic trinomial can be rewritten as a product of two binomials, where the first two terms gives me an a squared, so that's a times a, and the second two terms gives me a 24. However, since this is a positive, they're either going to be both positive or both negative. Since my middle term is negative, that means both the factors must be negative. And again, they're going to add to give me a negative 11. Hopefully you can kind of see these two numbers are going to be minus 8 as well as a minus 3. And that's going to equal 0. All right, so now we can apply the zero product property, right? So I can say a minus 8 equals 0 and a minus 3 equals 0. But now, rather than doing that, now we can use our substitution. Now we can say let a equals x squared minus 1, right? So now we can substitute back. So we can say x squared minus 1 minus 8 equals 0, and x squared minus 1 minus 3 equals 0. So therefore, this is x squared minus 9 equals 0, and this is x squared minus 4 is equals 0. So x equals plus or minus 3. You add 3, take the square root. And this one would be x squared equals plus or minus 2. Or x equals plus or minus 2, sorry. There you go. The next question was solving a system of equations by solving, or by graphing, sorry. Of course, solve it by solving, obviously. So in this case, if we just want to graph this, so we have a slope-intercept form. So we have -2. So we go down -2, and then we go up 1 over 4. So up 1 over 1, 2, 3, 4. And that's it. And that's not going to match on there. Jeez. Why would they make us, oh, the x equals 4. Okay, that's fine. And then the other one is going to be at x equals 4. Well, x equals 4 is a vertical line, right? So that line continues indefinitely. And then we have x equal 4, which is 1, 2, 3, 4. You could say that line crosses all the way there. Right? You can say, all right, so the intersection or the solution to a system of equations is where they intersect. And you can see it's going to be that point, which is 4 comma negative 1. Now, in the next example, we could do the same thing. We could graph these and figure their intersection point. But that does not look very easy for these two because they're not in slope-intercept form. So we'd have to do a little manipulation. We have to change things out and to get from there. So in this case, we have 4x minus y equals negative 1. 2y minus 8x equals 2. Okay. So we could either do substitution or we could do elimination. And typically when my y is isolated, I like to use, substitution. So you know what? That's what I'm going to do in this case. You could do elimination just as easily, I'd probably say. But for, I don't know, for whatever reason, I like to have let's use elimination. I think, let's just go and use elimination. That's fine. So when we're doing elimination, because substitution, then I have to solve for it. It's a couple more steps. Let's just use elimination. Only time I like to use substitution when it's not isolated is when it has a coefficient of 1. In this sense, since it's coefficient negative 1, I'm like, you know what? Let's just go through it. Because here I only have one scalar that I need to multiply by. So what I am referring to here is when we're doing elimination, we want to add our two equations here. All right. And what we want to do when we add them, we want to get a coefficient of 0 in for one of our variables, and that's going to technically eliminate it. Now, what I recognize here is I'm a little slow to figuring this out. I didn't see it before, is that my x and y's are not aligned. So the first thing you always want to do is align your variables. Okay, that's a common mistake. Make sure your y's are over your y's and your x's over your x's. Okay. Now what we want to do is get the coefficients to be the same. And especially if you can get one positive, one negative, then you can add them instead of have to subtract them. So I'm going to multiply the top equation by a 2. And by doing that, I get a negative 2y plus 4x equals negative 1. And then I get a 2y minus 8x equals 2. Now, when I add the two equations, you can see here that becomes a 0y, right, which is a 0. Here, I get a negative 4x equals 1. All right, so I divide by negative 4, divide by negative 4, x equals a negative 1/4. Done. But that's for x, right? So again, when we're solving a system of equations, we're looking for the x as well as the y coordinate. So what we're going to do is I'm going to plug x into the other equation. Now you can plug it into either one of these equations. I'll plug it into the top equation because it seems a little bit easier to go ahead and solve here. So I do 4 times negative 1/4 minus y equals negative 1. Here I get a negative y minus y equals negative 1. So add 1. Well, that's going to give me 0 here. So it doesn't really matter. Y is equal to 0. So my coordinate point, or the solution point where they would intersect, would be negative 1/4, comma 0. And ta-da, done. All right, question number 5 is solve the inequality. So when we're looking for the inequality, what we're going to do is let's just kind of forget about this. Let's look at what this graph would be. Okay, let's forget about the inequality for a second. Let's just look at the graph. So if we're going to do this graph, if I said, to graph this, you could look at vertex form, but or putting it into vertex form, but that doesn't look like very easy. And we could look at finding the axis of symmetry and it's like, oh, that doesn't look like very much fun, and creating a table. No. So what I'm going to do is I'm going to say, well, what information can we figure out? Well, we can easily find the x-intercepts and the y-intercepts, right? The x-intercept is when y is equal to 0. The y-intercept is when x equals 0. So if I put x equals 0, I get x squared plus 5x plus 6. All right, I can factor this down. What two numbers multiply to give me a 6, add to give me a 5? I say, oh, that's 3 and 2. So here goes x plus 3 times a x plus 2. Okay, so x equals negative 3. X equals negative 2. And then the y-intercept is you plug 0, so your y equals a 0 squared plus 5 times 0 plus 6. Y is equal to 6. Okay, so now let's go and graph this. So we have negative 3, so 1, 2, 3, and negative 2. And then we have y equals 6, 1, 2, 3, 4, 5, 6. Oh, right there. Okay, so the graph is going to look something like this, right? And basically what we want to do is say, all right, when is this equation? When is this equation going to be greater than the x squared minus 5x plus 6? Well, again, you can play with some values, but hopefully you can kind of see like this value, the y value, is going to be greater than when it's less than -3 or greater than less than -3 or greater than -2. But let's just go and plug with some values. Let's plug in 1. Where you see where it's going to be greater than these, so then 0. You can plug in these 0, 6. Yeah, you can plug in that point. You can see it works. I tied my tongue on as far as on this, but you can see where the y value is going to be greater than or equal to these x coordinates, where this is going to be positive, and you can see it's going to be when x is less than negative or less than -3. And x is going to be greater than -2. So less than -3, greater than -2, it's going to be greater than 0. Because you can see like these two values are going to be 0 in this case, right? Obviously they're equal to 0, and you can see it's less than 0 down below here, and it's going to be greater than over to those two areas. Do the whole equation. Yes, you have to distribute to the whole equation. Did I not distribute to the whole equation? Please tell me I did. Did I not? 2. Oh, you got to be kidding me. I messed up that whole problem for you guys. Jeez. Yes, you have to. Come on, Mr. McLogan. What's up with that? I got to redo this whole thing. So I'm not going to talk my way through it as much. But yeah, you got to make sure you distribute this whole way through, guys. Thank you so much. Who is that? Who is that? Who did not? Yeah, I did not cancel out the y. But yes, you distribute the rule. Yes. I got to multiply everything, guys. Thank you for keeping me honest. 8x equals -2. 2y minus 8x. Ooh, maybe this is why the person had trouble. That's kind of interesting. So when you distribute, what do you get? You get a 0 is equal to 0. So what that tells us actually is infinite. I don't know why I did double I's. Infinite many solutions. So yes, I was being a little lazy, going a little fast. I do apologize for that. I don't know why. I keep on looking up here. Yeah, you could look into the Cramer's rule as well. And obviously if a student's depending on, I have no idea where everybody's math is. That's what's always kind of tough about doing math in a live stream. There's many different ways to approach the problem. And, but everybody is coming from a different level where they've learned this. So I got to do my best. But I apologize for that. Yeah, you got to be careful. But anyways, the reason why it's infinite many solutions, because it doesn't matter what you plug in for x or for y. It doesn't matter what you plug in there. Always like when you set these equations, always going to be true, basically for these. All right, so now let's get into the next one, which is actually my last question. So if you guys do have any other questions that you guys do have, I can't get to everybody's question, but I'll be more than happy to maybe address a couple questions here and there if you guys have them. So feel free to add them into the chat. I can hang out with you guys or just answer whatever questions you guys have for on this. Yes, I know Cramer's rule is very straightforward, but a lot of people, if they're in Algebra 1, have not learned Cramer's rule, so that really wouldn't make as much help for them as far as what they need to know how to do that, for an Algebra 1 or maybe an Algebra 2 type problem, so that's why I believe that from the certain problems that I had, that's where I wanted to address that problem for. And yeah, could you put this in slope-intercept form? Yeah, I mean, like I said, there's many different ways we could have solved that problem. We could have put it in slope-intercept form. We could have graphed it. We could have used substitution. We could have used Cramer rules. We could have used matrices. A lot of different options for us. All right, so use the figure to find the exact value for cosine of 30 degrees. All right, so let's kind of reorient this triangle here and say that's 60 degrees, that's 30 degrees. Okay, so that's the hypotenuse, that's my adjacent side, and that's square root of 3. Okay, so remember cosine of an angle is the adjacent side over the hypotenuse, right? So if here's 30 degrees, my adjacent side, so I could say cosine of 30 degrees, is going to be the adjacent side. The adjacent side is always the side, sorry, look over here, that is between the angle and the 90 degrees. So that's going to equal square root of 3 over the hypotenuse, which is 2. And there you go, that's it. So I'll just kind of like remind you here. So if here's my angle theta, if I said what is the cosine of theta, that's going to be the adjacent over the hypotenuse. Adjacent over hypotenuse. And the other side is opposite. Okay? No, the equation would be no solution if it was like 0 equals 5. Then obviously that's incorrect, right? So that would be an example of no solution. All right. So let me know if you guys have any other questions. Charles, I got you with the projections. I saw your question, but I didn't be able to get to it. I don't teach projections in much of my pre-calculus class, or at least I haven't taught them in a while. So it's just something I'd have to go back over and look over. So that's why I didn't cover the projection on U and V. It's not something there. I just have to go back and look at the form. I just don't remember from in there. So I do apologize. You're one of those questions where I looked at, I was like, I don't remember off the top of my head. It's not something that I currently, even though we already covered vectors, it's not something we usually cover in our chapter. So unfortunately, it's just not something I've like recently gone over. So I'm not sure my explanation would be great, nor do I remember the exact formula for the projection. I have a question. One leg of right triangle is 1 centimeter longer than the other leg. The length of the hypotenuse is 9 centimeters greater than that shorter leg. Find the length of the 3 sides. All right. I don't really like these word problems one, but I think we can work on this one. So I wonder, no, I can't, man. Actually, you know what? I wonder if I could do this. Let's put this back. All right. Let's see if I can store. Let's see if I can save this. Oh, I can. Haha. Whoa, wee. Well, hey, Marcelo. Hopefully I said your name right. One leg of a right triangle. Okay, so let's draw a right triangle. All right, so we have one leg of a triangle is 1 centimeter longer than the other leg. All right, so let's call the one leg X. And if the other leg is 1 centimeter longer, then that's going to be X plus 1. And then the length of the hypotenuse is 9 centimeters greater than that of the shorter leg. So obviously the short leg's here, so that's going to be X plus 9. Find the lengths of all 3 sides. Okay, so using our Pythagorean theorem, we could say X plus 1 quantity squared equals X plus 9 quantity squared. So we have X plus, let's see, we can expand this, X squared plus 2X plus 1 equals X squared plus 18X plus 81. All right, so I could subtract those on both sides. Those would divide out. That gives me a 3x plus 1 equals a 18x plus 81 minus a 3x minus an 81. All right, so I get a, let's go over here. So I get a negative 80. That's kind of weird. Negative 80. Oh, I guess it's just the x, but yeah, it's not going to represent the sides though. 80 equals a negative 15. X. So divide by negative 15, that's going to be what, 6? Or negative 6? X equals a negative 6, which is just kind of weird. I'm not sure if I missed a negative or not, because if X equals negative 6, then those would be like negative side lengths, which I guess maybe they could be in like a different direction or something. So that'd be negative 6. This would be a negative 5, and this would be a 3. Not sure if I did that right. Please let me know if I made a mistake on that one, because I feel the math was obviously correct, but I'm not sure if I made like an algebraic mistake. You forgot to square the x. Of course I did. Thank you so much. I was wondering, I'm like, something's wrong. Something's not right. I said it, but I didn't do it. There you go. X squared. All right, so now this is going to be a quadratic. Nobody wants to do a quadratic. Thank you. I'm making mistakes all day today. All right. So let's go ahead and read. Oh, I said it, but I didn't cover it over this. So let's go and redo this here. Oh, man. Okay. All right. So slow down, Mr. McLogan. So we have a 2x squared plus 2x plus 1, right? And then equals a x squared plus 18x plus 81. Okay, so let's get everything to the same side. So when I do that, I'm going to subtract an x squared on both sides, subtract an 18x on both sides, and I subtract an 81 on both sides. When I do that, I get 0 equals x squared minus 16x, and this is going to be minus 80. All right, so now I got to figure out what two numbers multiply to give me a negative 80, add to give me a negative 16. Making me think on the spot now. Marcelo. So let's see, negative 80. So I have that. So let's go through our numbers. So we have negative 80 time, or let's just do, forget negative. Forget the negative. You don't really need to worry about the negative. Let's just do 80. So it's going to be 80 and 1, right? We have 40 and 2. Let's see here. We could do 10. You could do 20 and 4. Ooh, 20 and 4. That has a difference of 16, right? So then I got to think, all right, well, if I have my middle term as negative, that means 20 should be negative, right? So 0 equals a x minus 20 times an x plus 4. Okay, so I get x equals a positive 20 and x equals a negative 4. Well, this doesn't make sense, right? Remember the problem I just told you? Like, that doesn't make sense to have a negative side length. So that's going to be an extraneous solution. So we'll say x equals 20. And then this side length is going to be a 21. And then this would be a 29. There you go. Now it makes a little bit more sense. All right. Hopefully that was helpful for you. And sorry for the mistake again. All right. Let's see, guys. Let's try to get to 10. Maybe. Right? See how much time. I got 3 minutes left. Who's got a question? What happened to your face? Man, everybody, I guess my face, I got to get my face better for sure. So I fell off my bicycle and I hit my face on the pavement and it sucked. But I did a little do better. Law of sines. Yes, that is the law of sines. But we can't see the down right part. Oh. Can't see the down. Oh, well, hopefully that was fixed for you. I think because I solve equations for some reason. Well, Cerebral, I actually did 2 systems of equations. I did elimination here, and I did a substitution here. So hopefully that was helpful. And I have a lot of questions. I think you need a Snickers. Yeah, seriously. I need to slow down doing my math, which is always the thing. Could you explain the roots of unity? I'm not sure if I understand your use of the roots of unity. Midray, thank you for you're very welcome. Yes, I mean, I go through calculus. I haven't taught calculus in years, though, so that's why I don't cover a lot of calculus problems. And if you, on the beginning of my stream, I was talking about one of the things I want to spend a lot more time on is just going back and reviewing a lot of, because I get a lot of people always asking me about calculus. And like when I'm teaching calculus, my brain is like in the calculus mode. But since I haven't taught it in the last 2 years, and it's been a way too long since I went over it, I just kind of like, I don't cover a lot of calculus on my live streams just because like, I want to make sure the explanations that I have are like pretty well like versed. And the same thing like Kramer's rule, like I don't teach Kramer's rule, and it's been a long time since I went over Kramer's rule. So I don't like to go over and teach things that I'm not going to have a great confidence in like of like quality explanations. To go through it. Like obviously I could stumble my way through stuff and maybe like look up something real quick, but I'm like, if I don't have confidence like in my explanation, or it's just going to take me a little bit of time just to like revise that, I just decide not to, cover, because I don't think it's going to be worth many people's time for me to not provide them like with a quality explanation. So that's why a lot of calculus topics I haven't talked about or gone over as much, just because it's not something that's as much relevant that I'm currently doing. I'm teaching Algebra 2, geometry, and pre-calculus at the moment. So, as in the 8th roots of unity, my book, I'm not sure, Charles, for this. Well, Marcel, you are very, very welcome. How do you do direct and indirect proofing? That's a very detailed. I'm not sure if I could be able to get into a lot of that. But if you have any questions on the indirect direct proofs, that's much more of a that's a great question, but a very much more as far as a detailed explanation for, or a little bit more of a longer that I'd be able to expend from on this for that. You are very welcome, Shady. I stumbled through high school. Oh my God, I love your videos. Currently in college. Well, very awesome, Victoria. Oh, Majestic. All right, you know what? I am in the United States, but Majestic is giving me a question that does not look like fun at all, but it's at least a division problem, which is fairly straightforward. No. So I will cover that. And let's see. Where is that? Okay. Actually, I don't have many of these like on my channel, actually. So that's why I kind of want to do one of those, see what happens. And then, oh, I love vaping. Well, thank you very much for your super chat. I greatly appreciate that. All right. Live and serve. Thank you so much for your comment. But please, you only need to type something in once. We don't need to repeat from there. All right. Will you teach direct and indirect present feature? Yeah, I mean, I definitely will. I mean, obviously, if you give me something a little bit more of a pointed, question, that's definitely something that I can address like more directly, no pun intended, from in there. But yeah, a lot of times when I'm doing my problems on like super chats, and again, like proofs, I haven't gone over. I think I have some content on proofs and like indirect and direct proofs, but not a whole bunch. That's something actually a little bit more I'd like to spend a little bit more time helping students with, because I think the ability to be able to write proofs and indirect proofs is something that I like love and miss, that I think will be that I'd like to kind of go back and like refine my explanation. So probably not something that I'd be covering, but you guys can also go ahead and always check in to your Discord or submit your questions in for next week. Can you tell me how to convert a vector form of plane to a Cartesian form? I'm not sure what type of vector, what you mean on the Cartesian form from that. So maybe if you can let me know, I'm not sure of that. Can you cover a binomial theorem? Again, kind of a little bit more of the context of what you're looking for in the binomial theorem would always be helpful for there. And yeah, I mean, you can cover like the Pascal's triangle. You can think of the Pascal's triangle. You can look at the binomial expansion. So I probably just need a little bit more from there. Divide by 5, I think. For this. All right, can you tell me how to convert? I'm not sure what you mean the vector form. I'm not sure what the vector form to Cartesian form. Why is log 10? Good question, Dragon. I'm not 100% sure. Obviously we have base 10 is our standard counting, right? So I think that would probably have something to do with it. No, I fell off my bicycle. That's why my face looks like this. Do you do Calc 2? If not, do you have any suggestion for a channel that does? Yeah, I think Professor Leonard has a Calc 2, which is awesome. And I would recommend, I know a lot of people have recommended his channel for like Calc 2. And I mean, there's just an awesome, whole awesome, great people that are teaching like upper level mathematics that I would just say, go ahead and watch some videos and you'll start seeing some other people that are posting content for sure. So I definitely look into that. All right. So I'm going to do this one last question, guys, because I still got school tomorrow. No, I don't want to do that one. Where is it? No, that one. All right. And this one's going to take me a little minute anyways. Okay, it says, could you do 6x cubed minus 6x? All right, so we can't use synthetic division. We have to use the long division, so which I know a lot of students do not like doing. So that's why I figured I'm like, hey, well, let me do the problem then. So therefore, it's going to be 6x cubed minus 19x squared plus 19x minus 15. Okay, so again, when we're doing long division with polynomials, we are going to take our first term in our divisor and divide it into the first term in dividend. So 3x squared divides into 6x cubed, and a lot of people, will get this wrong. So what I always recommend with students is to write it over here. And hopefully from here you can say, oh, that just goes in there, not 6x times, that goes in there 2x times. Okay, so, and then once you divide that in there, right, that equals 2x. Then make sure you multiply it back times every single term. So 2x times 3x squared is going to be a 6x cubed. 2x times negative 2x is a negative 4x squared. 2x times 4 is going to be a positive 8x. All right, now you're going to subtract the rows. I'm putting parentheses around here, so we need to make sure that we're subtracting each and every one of these terms. So 6x cubed minus 6x cubed is a 0x cubed, so that's just going to be 0. Negative 19x squared minus a negative, so that's going to be a positive. So therefore, that's a positive 4, so that's a negative 15x squared. And 19x minus 8x is going to be a positive 11x. And then here you can subtract from 0, so that's going to be negative 15. All right, so now we do it again. So 3x squared divides into a negative 15x squared. That's going to be a negative 5 times. Negative 5 times 3x squared is a negative 15x squared. Negative 5 times negative 2x is a negative 10x. And negative 5 times 4 is going to be a negative 20. And then we subtract our rows. And here we get a 21x, and then this is going to be plus 5. So that is going to be a remainder. So our quotient, our final answer, is going to be 2x minus 5, plus you can take your remainder and then put it over your divisor. Okay. So, Barbarian King just comes in hot and then starts going in from there. Oh, man. All right. Very good. All right, guys. Well, thank you so much for joining on lesson tonight. I do apologize, guys. I know I wasn't able to get to many of your questions. I apologize for that. But please feel free, guys, if you do have any questions for next week, feel free to add them into the chat. I have the link here in the description, as well as my Discord server that you guys can go ahead and check out. Otherwise, I look forward to seeing you guys all next week and answering your questions. All right, guys, have a great week. Cheers.